This is a short video tutorial that I'm preparing for the playlist, which is called Transitioning from uh, Abacus to 3D Experience, or perhaps say it differently, transitioning to 3D Experience from the Abacus CAE. It is intended for people who are new to 3D Experience, so they may or may not know anything about Abacus, or people who are familiar with Abacus, but they would like to transition to the experience, mainly because the interface uh, is different, and there is integrated. It's an integrated platform with our CAD facilities and things like that. Uh, Keep in mind that the FEA solver in the 3D Experience program is actually the Abacus program. However, the interface and the icons and some of the functionalities are different. So it is not the case that if one knows Abacus, they can immediately get on 3D Experience and in no time basically to do the problem. All right. So the, the the playlist that this is being prepared for actually is looking at tutorials that are already done in a step-by-step way in the Abacus program. So I retrace the step to show the differences and the changes that are needed in order to make a one-to-one correspondence, if at all, with the Abacus program. Okay, so basically this is what I talked about. And the particular version of 3D Experience that I'm using is the R2022x, because this is an evolving code as far as the interface and functionalities. So the current interface that you see is actually for 2022. Now, the particular tutorial deals with the concept of circular symmetry or periodic boundary condition. And basically, if you have structures like this, let's say turbines or flywheels, etc., notice that there are units in it that can be isolated, and these are repeated in a circular pattern. Okay, so if one actually models one of these units, a sector that's taken out, then basically the other ones are all going to be the same. So these are some examples that you can see, and the cyclic symmetry or circular symmetry is actually in the model action path, and under the abstractions path right here. Here's the abstractions path, and notice down here it talks about cyclic symmetry or circular symmetry, which is exactly what we are referring to. For example, if you take a disk that's rotating at a constant speed about some axis, you don't have to model the entire disk. All you need to do is to take a particular sector, and in this case, it really doesn't matter because, for example, I can take maybe a 45-degree sector and repeat it 8 times around this thing. So but you need to select, in doing so, you need to select the periodic boundary conditions, the periodic surfaces. So this one, which is called main surface, and the one in the back that's called the secondary surface. And then you have to say how many units basically you have here. So if this is 45 degree angle, it goes around 8 times. And the axis of symmetry, obviously you have to construct it and get it. Now, the particular problem that I'm going to be concentrating on is this particular video tutorial on the Abacus program, which is done by the YouTuber here, Abacus Acumen, and the reference is given there. Now, uh, he's taking a 45-degree sector, and the only problem is that it's not quite clear in that video what the dimensions are, although I tried to get as close as I can to that, but that was not quite clear to me. Also, as far as this thing, this thing, think about it as a disk that's rotating about the axis of symmetry. It was not quite clear to me what the angular speed was. This is why, although I'm using the same geometry and although I'm referring you to this video tutorial, I'm not going to try to match anything. That is really not the purpose of this tutorial. Okay, so these are my dimensions, and one of the difference between the way I'm going to do it and the way it's done in that tutorial is that there in the Abacus CAE program, once you draw the sketch, you can actually make a pattern of it, circular pattern. That feature is not available in 3D Experience. However, instead of circular pattern, you can take this and rotate it 8 times, eight times basically by 45. It is possible to do it, but I will do it a different way. I'll create that sketch and create the part. Okay. All right. So let's go ahead and make this done here. Oh yeah, there is some online documentation, by the way, uh, in the program. So I have put a couple of them there in case you have to go back and read it carefully. So there is the part design. So on this horizontal plane, I will sketch. This is the XY plane. I would prefer if my view was different like that, so matches what I showed you before. So let's go ahead. First thing I'm going to do, I'm going to go to sketch, draw a line. There's the line, and this line is going to be uh, eventually is going to be something that I reflect half of my geometry. When I say half of my geometry, I create half of this sketch and then reflect it with respect to that line that I drew. So first of all, let me make this thing a construction line right there. This is a construction line. And I'm going to put an angle there, 45-degree angle. So between this and that axis, 22.5, that's half of 45. Okay, and now we're going to do the rest of the geometry. So I will make two circles, one centered at the origin and 25. Let me actually do the following. Instead of making circle, I rather make an arc. So there's circle, starts here, it goes there. This is not construction. So let me change that to non-construction entity. And by the way, to make my job easier, I want this point to be on that line. So that point control this line. I'm going to make it coincident. Let me try it again. That point control this line. We'll make it coincident. Coincident. Okay. Good. So this circle, the radius of it is 25 millimeter, and what you see there is actually this circle, the inside circle, 25 millimeter. So let's dimension this thing. 25. Very good. Then I do another one, 75 millimeter. That is this guy. So let's go ahead and draw another circle, another arc, center there, start here, there. I was careful to make it coincident as I was drawing this thing, so that's going to be 75 millimeter. Okay, so what you see there, oh, 75, not 45, 75. All right. Oh, the only thing is that this point is supposed to be coincident on that axis, so let me do that. Control that, and we make it coincident. Okay, pushed it down. Very good. Uh, Based on the strategy that this gentleman is following in his tutorial, I will do the following. I will create a rectangle here. Remember, you can make this thing any way you want. It's just that I'm trying to be as close as I can to what this fellow is doing. And then dimension that to be 5 millimeter. What I'm trying to do is I'm going to try to, this is the rectangle that I'm trying to make, and I'm going to clean it up in a minute or so. Okay, so, and this dimension from here all the way to there is 150 millimeters. So dimension from, let's say, this to that line, 150 millimeters. Very good. And now we're going to do a little bit of a cleanup here. So quick trim, let's see what we can get rid of. Okay, that is gone. Can I get rid of this? Yep. Another one. Oops. Another one is. Can I get rid of this? Yep. And yeah, and this one. Okay. Now let's see if we can get rid of this little piece here. Yeah. Okay. So what you see there is almost this half of this, except for the fillet that I have to make. So let's go ahead and make a fillet there. 5 millimeter fillet at that corner. Okay, so that's going to be 5 millimeters. Excellent. So now we're going to take all of these things that we created and reflected with respect to that axis. So this guy, control, maybe if I selected it with a trapped it like that. Yeah, so let's see if we can find mirror. Mirror with respect to this. Yep, very good. Okay, so that takes care of this. And exit, and we pad it by 20 millimeters. Notice that the thickness here is 20 millimeter. So we go to model, pad. There is, it's complaining about the fact that there is an open sketch there. Remember that line that I drew and used it for reflection purposes? That is an open curve. So what we can do is we can say, don't do that. Go back to that sketch. We clean it up. We're going to clean it up. Go back to that sketch. Let's do it from here. I bought a mouse that is not very responsive to this. So this line is not part of my sketch. So what it was a construction line, I think. There must be something else. Let's check out. Let's find out what's going on. Something else is bothering. Because this was a construction line, it should not have been a problem. But if you go to the under analysis, under sketch analysis, tells you what's there. So this line, okay, so let me delete this line. I don't know what that line is. There's a line somewhere here. Let me delete it. Okay, so right now everything is closed. Say okay, exit, and now try to pad it. Yep, okay. 20 millimeters, very good. Now notice that this is the shape that you see there. And if I wanted to, although the whole purpose of cyclic symmetry or circular symmetry or periodic boundary condition is not to have the whole model, but if we insist, we can always go ahead and make a circular pattern out of that. I believe under transform, let's see if we can find under the circular pattern is somewhere here. I'm gonna find it. Transform. Oh yeah, right there. Okay, right there. It was here on the transform circular pattern, and it says, for example, how many do you want? Let's make it eight instances, and for the complete crown, and for the it's asking for something reference plane. For the reference plane, let's select this and preview. Now, I don't want to do the entire model now. We don't want to do that. Okay, we also need to create the axis of symmetry and the axis along which this disk is rotating. To do that, I will create 2 points and a line between them, and that line is going to be used for axis of symmetry later on. I noticed that in the CAE program, all you need are the points. You really don't need the line, but I think here you need the lines. But let's go to the model. Under essential, two points. One of them is going to be 0, 0, 0 right there. That's one of them. And then another one. Did I create it? Right there. Okay, the other one is going to be, let's take a higher elevation. So maybe like that. Really doesn't matter. There's just some point up there. Okay, very good. Oh, so we have how many points? We have 2 points, 0, 0, 0, and the other one which is 25 inches above. So let's go create a line. So a line that goes from this point to, yep, point to point. Very good. Okay, that takes care of this. And now we're going to go to the structure model creation. We create a mesh. So let's use that entire body and parabolic or linear swept elements. So four layers through the thickness, 3 millimeter size. So let's update and see how it looks like. Okay, that looks good. All right, so that takes care of this. Now we're going to go to structure model. Oh, one thing I forgot to do here. Actually, I didn't forget. It's just that we can always come back and do that. But notice that the abstraction tab allows you to define the circular symmetry. If you go to the slides, you see that in the model, while we're in the model, we can create this thing that we want. So let's go ahead and click on the abstraction on the circular cyclic symmetry. You click on it. It's asking you to select the two surfaces. One is on this side. If it's bothering you, you can hide the mesh. And then the second one is going to be on that side. Order is not important here. And for the axis of symmetry, we're going to select this line. And OK. All right. Now we can go to the structure scenario creation. That's where you apply the load and restraints, if any. So let's use our finite element model. Okay, and under the procedure, we do a static step. Let me make the time increment 0.01. Even one time increment, because this is a linear problem, is going to work, but I changed that thing to 0.01. And yeah, I'll leave the maximum as 1. This is a linear problem, it doesn't matter. And I will uncheck the geometrical nonlinearity effect, and then we say OK. Now, under restraints, you were told that these two inside faces are clamped. So this one and that one, they're clamped. Okay. And the load is centrifugal load. So we go here, centrifugal force. The whole model, obviously, axis of rotation is that line that we created, right? And I took 750 RPM. And I think that's what this gentleman used, but I'm not absolutely sure. So we say, okay, good. That's pretty much it. There's nothing else that needs to be done. Now, this business of cyclic symmetry in the Abacus CAE is done in the Interactions tab, but not for us because we don't need it. It's done in the model the way we did it a minute ago. Okay, so let's go to simulation, do a quick model check. Do a quick simulation check. If there are some obvious error messages that are going to pop up, remember, we are not trying to match any results. We're just trying to see what the corresponding steps are when you go to the 3D experience to do such a problem. And it can be directly compared with the steps that are needed to follow in the Abacus CE program. Okay, and finally, we're going to run it. It's just finished extracting the results. Okay, so let's close this. This is the initial step. Obviously, one means just is zero. Then as you go down, and I just noticed that this thing is actually bending in. So let me stop this thing for a second. Obviously, there's something wrong. We forgot to do something. It can't be like that. And I have a fairly good idea of what the problem is. You see, when I created my abstraction, cyclic symmetry, one thing I forgot to do is to tell the software that there is 8 sectors. I just left it inadvertently left it as 1. 8 sectors. So we say okay. Now we go run it again. There's no reason to. We don't have to go to scenario. There's no reason to check these things because it's going to work. So let's just run it. That was a surprise. Okay, let's go ahead and run. By the way, those 2 points and the line that I created in order to define the axis of symmetry and axis of rotation. In all likelihood, I could have used an axis system, created the XYZ coordinate system at the origin, and used the vertical, presumably Z, as the axis of rotation and axis of symmetry. In other words, I didn't have to create 2 points and a line. Just the coordinate system there would have been sufficient. Could have chosen the axis for that. There. Okay, that's a lot better. Yeah. So notice that this is in megapascal. Things can be, you can change it. You can change the mesh size. So we know how it works. Good luck.